Welcome to this video on real-life graphs. You can find the PDF of all the questions, clues and solutions on mathsupgrade.co.uk. The first set of questions here are all non-calculated questions. Question 1 is a 5-mark question. The first part is 2 marks and it states that phone calls cost Y pounds for X minutes. The graph gives the values of Y for values of X from 0 to 5. So here you can see the X-axis. This is the number of minutes you spend on the phone, and this must be the cost of the call. Give an interpretation of the intercept of the graph on the y-axis. So the intercept is where this line cuts the y-axis. So this is the intercept here. We need to give an interpretation of what it is. Since the intercept is where x equals 0, that's where the number of minutes you spend on the phone is 0. So this must be initial charge. Even if you don't spend any time on the phone, this must be the initial charge of the cost of the call. So this is known as the standing charge. So that's what I put here. This is the minimum cost of a phone call for 0 minutes, the standing charge. Part B states, give an interpretation of the gradient of the graph. Now the gradient is how steep the graph is, right? Since the steepness is basically the change in the vertical distance divided by the change in the horizontal distance. It must be this value here divided by this value. So this axis here represents the cost of the call, and this axis represents the length of the phone call. So the gradient must be the cost per minute, the cost in pounds divided by the time in minutes. So that doesn't include the standing charge. Okay, so that's literally just the gradient. It's the cost per minute. Part B, find an equation of the straight line in the form y equals mx plus c. So y equals mx plus c, the number or the coefficient of x, right, so the number in front of the x is known as the gradient, and the number which is added on or subtracted here is known as the intercept. Okay, so we need to find the value of m, the gradient, and the value of c, the intercept, right? So the value of c, let's do the value of c first because that's really easy. The value of c is just where this line cuts the axis, it's the intercept, right? So you can see, you can read off here, it's a 0.5 or a half, right? Now the gradient is defined as the steepness of the line, and it is the change in the vertical distance, the change in y, divided by the change in x. Now you can draw a right angle triangle wherever you want on this line. Okay, so you can draw it from the top here to the bottom here, a huge right angle triangle, or you can draw a small one. It doesn't matter where you draw it, the gradient will be the same since it's a straight line. I've drawn it here, and the reason I've drawn it here is I've chosen points where I can easily read off the values on each axis. So this point here, the y-axis is 5, and at this point here it's 2. So the difference is 3, so the change in y is 3. And at this point here, the x-axis shows 3, and at this point here, the x-axis shows 1. So the difference is 2. The change in x is 2. The gradient is the change in y divided by change in x. So that's 3 divided by 2, which is 1.5. So I've put here, the equation is y equals mx plus c. It's always in this form, and so we've put y equals 1.5x plus 0.5. You can leave these as fractions if you prefer, but that would be 5 marks for that whole question there. Question 2 says the graph shows the temperature T of the coffee in a cup at a time after small t minutes. So here's the temperature, capital T, along this axis, the y-axis, and here's the time in lowercase t, in minutes. Okay, so you can see, for example, as soon as you make the cup of coffee, it's virtually 70 degrees Celsius. But then the temperature goes down very, very fast. It's a very steep line down here. So it gets very cold. The rate at which it gets cold is very, very fast. But then it starts to just level off, and then it basically gradually reaches 20 degrees Celsius. So it starts cooling really quickly here, and then the rate at which it cools starts getting slower and slower. So we need to find an estimate for the gradient of the graph at time 5 minutes. So we need to find the gradient of this graph at time 5 minutes. So where's the time axis? Here's the time axis along the bottom here, the x-axis. Here's time 5, so you need to go from 5 straight up to where you reach this line. So where you reach that line, you need to draw the tangent to this curve, the tangent to it. The tangent is basically a line which just touches, a straight line which just touches the edge of the curve. You can see the slope of the curve at that point is about there. So use a ruler and pencil to draw a line similar to that. And then you need to find the gradient of that line that you've drawn there. So again, you need to draw a right angle triangle anywhere, but which has got that line as the longest side of the right angle triangle. So I've drawn it here. Okay, I can draw it above it if I want to, that doesn't make a difference. And the gradient, remember, is known as the change in y divided by the change in x. So the y divided by x. So the vertical distance divided by the horizontal distance. So here's the vertical distance, 50 to 20, so that's 30. And here's the horizontal distance, 10 to 0, so that's 10. So it's going to be 30 divided by 10, which is going to be 3. Now, since it's a negative gradient, it's going downhill, it's going to be negative 3. So don't forget that negative sign there. And that is 2 marks. In part B, we need to explain what the gradient means. So just look at the labels on the axes. The gradient is the change in the vertical divided by the change in the horizontal. So the vertical axis is showing us temperature, so it's the change in temperature divided by the change in the minutes. So it's the how much the temperature changes per minute. How much the temperature changes per minute. In other words, the rate of change of the temperature. And since it's a gradient of 3, negative 3, it's dropping by 3 degrees Celsius per minute at that moment in time, at that moment, which is at 5 minutes after we started measuring. And that is 1 mark for that final question. Question 3 involves real life graphs with ratios. We're told that the height in x centimeters and the width in y centimeters of TVs are in the ratio 9 to 16. Use the information to draw a graph to show the relationship between the height and width of TVs. Use values of x from 20 to 80. So let's just look at this grid that we're given. So the x-axis represents the height and the y-axis represents the width. And you can see the height is going from 20 to 80, the width from 20 to 160. So we need to do the height, the values of x from 20 to 80. So 20 to 80 is along the whole graph. Now this ratio here, this is the clue to this whole question. What we need to do, we need to find if the height is 9 and the width is 16. So the height is 9, width is 16. The problem is the height of 9 isn't on this grid. This axis doesn't go to 9, it starts at 20. So can I find another ratio, right, which is equivalent to 9 to 16? So another ratio I could do is, for example, 18 to 32, since this is equivalent to 9 to 16, so 18 to 32, can I plot on here 18 as the height and 32 as the width? Again, 18 isn't quite on this axis, so let's find another equivalent ratio, 27 to 48. So I've just times the left hand side by 3 times the right hand side by 3, 27 to 48. So I can plot 27 and I can plot 48. So 27 across, 48 up would be somewhere around there. And then I can find another equivalent ratio, 36 to 64, plot that, 45 to 80, plot that. I can plot lots and lots of different values, and eventually I can see they all form a straight line. So this is the straight line. Okay. Now, part B, it says a TV has a width of 90. Use your graph to work out the height of the TV. So it's got a width of 90. That means I can go from the width axis, which is the y-axis here, from 90 across to the line. And when I meet the line, go straight down vertically until you read off the height of the TV. And you see the height of the TV is 51 centimeters to 1 mark. The whole question there was worth 3 marks. Question 4 is another calculator question, and it shows the depth d centimeters of water in a tank after t seconds on this graph. So you can see the depth of water at 0 seconds was about 210 centimeters, and then he went straight down until there's no water in the tank after 140 seconds. I need to find the gradient of the graph. And the gradient is the rate of change in the y-axis divided by the x-axis. So draw a right angle triangle anywhere on the grid where the longest side of the right angle triangle, the hypotenuse, is the line that's represented on the graph. So I've drawn it like this. The reason I've chosen these 2 points here is this point here I can easily read off the value of 180 and 20, and at this point here I can easily read off the value of 60 and 100. But you can draw this right angle triangle anywhere you want. You can be as big or as small as you want. I've just made it easy for myself to read off the values. So the gradient is the steepness, it's how steep the line is. First of all, you can see it's negative, it's going down, so it's going to be a negative value. And it's the change in y divided by change in x. So the change in y, it goes down from 180 to 60, so that's a drop of 120. And the x goes from 120, so that's again a drop of 80. Since it's negative, when I divide these two numbers, I'll put a negative sign in front, and that's 1.5. So negative 1.5 on the calculator, and that's 2 marks. So explain what the gradient represents. So just look at the axes. So we've recognized gradient as the rate of change in the y-axis divided by the x-axis. So it's how much the depth changes with respect to time. So it's the rate of change of the depth of water in that tank. It's the rate of change of the depth of water. And we know the depth goes down by 1.5 centimeters every second. We know that since we worked out the gradient here. So the depth reduces by 1.5 centimeters per second. And that's your 3 marks for that question. Question 5. The graph shows the cost of using a mobile phone for 1 month for different numbers of minutes of calls made. The cost includes a fixed rental charge of £20 and a charge for each minute of calls made. Work out the charge for each minute of calls made. This question is worth 2 marks. The charge for each minute of calls made is essentially the gradient of this line. The intercept of this line is the standing charge. That is the cost without even making any calls. So it would have cost us £20 without even making any calls. So to find the charge for each minute of calls made, I just need to find the gradient of this line, since the gradient represents the cost per minute. So I'm just going to draw a right angle triangle anywhere underneath this line. I've drawn it as big as possible here, just because I can read off this value really easily, and I can read off this value really easily. This value here, the y value here, is 35, and the y value here is 20. So 35 minus 20, which is 15. So that's 15 for the change in y. The change in x is 500 and 0. It'll be 15 over 500. 15 over 500. This number is in pounds, since it's in pounds here. So to do 15 divided by 500 on the calculator, you should get 0.03, which is in pounds, so it's essentially 3 pence per minute, and that's a sensible answer. Question 6 gives us the volume of a liquid litres in the container at time t seconds. So this axis represents liquid, the volume of the liquid, and this is the time. So you can see in this container, as we started measuring it 0 time, there's 4 litres, and it went up constantly. After 8 seconds it had 16 litres in. We need to find the gradient of the graph. So the gradient, remember, is given by the steepness of the line. It's a straight line, so you can draw this right angle triangle anywhere you want. I've drawn it here just because it's easy to read off the values here. At this point I can see the y value here is 10 and the x value here is 4, and at this point it's 4 on the y-axis and 0 on the x-axis. So the change in y, the vertical distance here is 10 minus 4, which is 6, and the horizontal distance is 4 minus 0, which is 4. So 6 divided by 4, which is 1.5 on a calculator. Explain what the gradient represents. So the gradient here, look at the labels on the axes. The gradient represents how much the y values change with the x values. The y values here is the volume, so it's how much the volume changes each second. So it's the rate of change of the volume. In other words, the volume goes up, it's increasing by 1.5 litres per second. Part C, explain what the intercept represents. We're told the intercept is here 4. So what does the intercept represent? The intercept here represents the volume at 0 seconds. Look, 0 seconds. So it's the starting volume, it's the starting amount of water in that container when we started measuring. The whole question there was worth 4 marks. Question 7. Judith and Simon are organising different parties at a hotel. The graph can be used to find the cost in pounds for the numbers of different numbers of people. So here's the graph. Let's look at this axis. This is the cost, and this is the number of people. So you can see, as expected, the more number of people that the party has, the more it costs to host the party. So you can see here, if you have no people, it will still cost £100 to host a party. Obviously, as the party increases in size, for 50 people, for example, it would cost nearly £1,000. Judith has £700 to spend on a party. Find the greatest number of people she can have at her party. So £700, let's find £700. Here's the pounds axis. £700 goes straight across and read off the value off the bottom axis. So that is going to be 34 people. Simon's organising a party for 20 people. Use the graph to find the cost. So 20 people, this time, number of people is on this axis. 20 people straight up vertically with a ruler, straight across, and you can see, read off the value, it's £440. Part C, more than 20 people want to go to Simon's party. Work out the cost for each extra person. So Simon initially planned for 20 people. More than 20 people now want to go. What's the cost for each person? The cost for each person is given by the gradient of this line. Look, this is the cost. So the vertical distance is the cost. The number of people is the x-axis, the horizontal distance. So if I find the gradient of this line and I do the cost divided by the number of people, that'll give me the cost per person, the cost for each extra person. So I'm going to find the gradient here, and I've done that in green. I've drawn a right angle triangle anywhere underneath this line, as big as you want or as small as you want. I've drawn it here so because I can easily read the value of this point, which is 840 here, and this point, which is 100 and 0. So the gradient is given by the change in y divided by the change in x. The change in y is 800 minus 100, which is 700, and the change in x is 40 minus 0, which is 40. So it's 700 over 40, which with the calculator is £17.50 for each extra person. And that question there was worth 4 marks. Question 8, the last question in the booklet. Carl ran in a race. The graph shows the speed in meters per second, t seconds after the start of the race. Write down Carol's speed 3 seconds after the start of the race. So let's look at the axes here. Here I've got speed in meters per second, and here I've got time in seconds. So her speed in meters per second, t seconds after the start of the race. So you can see her speed here. At 0 seconds, her speed is 0. So she goes quite fast, quite quickly. It's quite steep, this line is. Then she obviously here reaches her top speed after about 7 seconds, and then her speed starts to come down. So we need to write down Carol's speed 3 seconds after the start of the race. Well, here's the start of the race, 0. 3 seconds would be here. So you need to go with a ruler straight up from 3 seconds, draw a line. As soon as you reach this curve, go straight across horizontally with a ruler and read off the value. So here you're going straight up, and here straight across. You can see it's about 6.6, and the units are meters per second, because that's what's given on the axis there. Part B, write down Carol's greatest speed. So greatest speed, here's the speed axis. which is the greatest value we can read off. The greatest value is this point here, which you can see just less than 10 meters per second. It's about 9.8 meters per second. Part C, there were 2 times when Carol's speed was 9 meters per second. Write down the 2 times. So let's look for 9 meters per second. Here's meters per second, the speed on this axis. Go straight across with the ruler, horizontally. As soon as you reach the line, read off the value of the bottom axis. So here it's about 5 seconds, but it's also 9 meters per second here as well. And that is about 9 seconds. So it's about 5 seconds and 9 seconds. The whole question there is worth 3 marks.